All right, well, welcome back, my geometric minions. It's come to my attention that we need to do a quick review of slope. You know, we've been looking at distance formula lately, and the question has come up about slope. So let's just knock this out really fast, and we'll see what we got. So first of all, what is slope? When you look at slope and you write that down. So go ahead and hit pause, write down what you think a definition of slope is. Okay, so we look at slope, a couple of different things. One, this is the change in the y divided by the change in the x. And that triangle there is the delta symbol. It's Greek for change. So that's what it is, okay? You may have learned slope as rise over run, okay? That's what it is. It's also y2 minus y1 over x2 minus x1. In essence, it's the horizontal change, or excuse me, the vertical change over the horizontal change. So it's how much we look at changing. Now, there is a formula. There is a slope formula, okay? And that's what's already written over here, and this is a quick way for you to find it. If you want the slope formula, here it is. It's y2 minus y1 over x2 minus x1. So this means when you plug it into two coordinates, x's and y's come from a coordinate, that's what it is. Now I have, my preference for me is right here. I'd rather simply look at it and see, hey, what do the y values change over what do the x values change, and then go from there. Now, when you talk about slope, there's a couple of things we can look at. When you look at slope, you've got to look at the four possibilities. One, is it increasing? Okay? Is the slope increasing? That means, is our line going up? Is it a positive? Okay? Is it positive? Is it increasing? The second choice, obviously, from increasing is decreasing. So when you look at the slope, either looking at the graph or looking at the coordinates, is it going down? Okay, this is said to be a negative slope. So this is a negative slope when we look at this one. The other one is a constant slope. Okay, so a constant slope. This is one that is a horizontal line. So when you look at that, it is a horizontal line. This one, a constant slope, has a slope of 0. Okay, it's got a slope of 0. So when you look at this one, now, the way you can tell, and I know several of you have fractions and things like that you freak out over, okay, is it constant or not? So we'll look at that one in one more second. So 1, 2, 3, and the last one is an undefined slope. An undefined slope. This is the vertical lines, the lines that are completely up and down. Undefined slope. It's not 0, okay? Difference between these two. An undefined number is when you try to divide something by 0. So if you have a fraction that have 4 over 0, it changes vertically. It changes vertically, but it doesn't change horizontally. So when we look at that, so it may change here, it may change 3. It's 3 over, but it doesn't change any this direction horizontally. So 3 divided by 0. 3 divided by 0, your calculator will say error, it will say mistake, a problem. So you can't do that. So that's an undefined slope. So there's the first thing we need to distinguish between. You've got to know what the difference is between them. So let's take a look and let's see. So let's start with the point 0, negative 5, and the point 5, 1. So let's start with that and let's find the slope. Now, symbol for slope that we'll use is m. Okay, so m is our slope. When we look at the slope, if we're going to use the point slope, or if we're going to use the slope formula, notice when we look up here at these different coordinates here, this is an x, this is a y. This is an x, this is a y. Well, I know somebody's going, hey, but remember a minute ago you said you're looking at these and you had y2 and x2 and y1 and x1. How do I know which one? Well, it's simply, this is the first coordinate, so it's x1 and that's the first y. This one is the second x, this is the second y. So if you want to plug in the formula, we said that our slope formula was y2 minus y1 over x2 minus x1. So that's what our formula is. We're looking at it. So let's plug them in. y2. y2 is 1 minus, all that comes from here, y2 minus. Now what's our y1? Our y1 here is a negative 5. Be careful there. Be careful when you're doing that, and don't forget the symbols of these numbers up here, negative. Okay, over x2, which is 5, minus x1, which is 0. So if we look at this, 1 minus a negative. Those double negatives, they cancel out, become a positive. So this says 1 plus 5. That's 6 over 5 minus 1 is 5. So there's our slope. Our slope is 6/5. That means it's positive, so we know we're dealing with a line that is going up. So there's where it is. Now, honestly, if it had been me doing this and I'm finding this, I would not have gone through this. I am not going to go through these steps right here. For me, I'm turning around and I'm going, hey, okay, let's find the slope. So if we look at it and we have these points up here, I'm going to be going, hey, changing the y's. So from -5 to 1, how far is that? Well, it's a positive change. They're getting bigger, and it changes 6. So the slope is 6 over horizontal change, changing the x's. How far does it change from 0 to 5? That's a positive. That's a 5. There it is. So that's how I'm getting it right there. So I'm going to plug that in. Now, so when you write this, there's where it is. Okay? So any questions? Hopefully not. Okay. So with that in mind, we've got this. Let me go ahead and start with these same two coordinates. Now, sometimes we need to write the equation of these lines. So sometimes we have to write the equation of these lines. And for that, we're going to use two formulas. First, we have slope-intercept. And then we have point-slope. So those are two formulas that we use to write the equations of lines. So slope-intercept, this is the one that is y equals mx plus b, okay? Where m is our slope and b is the y-intercept. Okay, that's why it's called slope-intercept, because it's the slope and the y-intercept. The m and the b, slope and y-intercept. Well, point-slope formula. Okay, so point-slope formula. This one looks like y minus y1 equals m times x minus x1. All right, well, if you're looking at this one, you're going, hey, what are these things that we're looking at here? Well, obviously, x1 comma y1 is a point. Well, I think my pen has stopped writing on me. This is a point. And then m is, well, we've already said m. M is our slope. So look at this. So that's the difference between these two. You can use whichever formula you want. Doesn't really matter. We start looking at these. Notice right here, anytime you've got a coordinate that 0 is in our first coordinate right here, this tells you that this is our y-intercept. So in the case of this, if you have 0 in the first one, we know that that's our y-intercept. So this one, slope-intercept, would be really easy to write because we know that our slope already, we've already found it, 6/5. Slope is 6 over 5. Our y-intercept is -5. So to write this one, we would write it as y equals 6/5 x minus 5. So there it is. Now for point-slope formula, we would write it, we would go, hey, we would pick one of these 2 points. Pick the easiest of them. I would pick this one. This is a much easier point. So we'd write it as y minus the y from our first point, -5, equals our m. We already found our slope. That was 6/5 times x minus our x coordinate. Well, that was 0. Okay. So to use point slope, then we distribute. Okay. After we combine right here, so we've got y plus 5 equals, now distributive property, 6/5 x minus 6/5 times 0 is 0. Okay, well, you're going, okay, well, there you go. So it's in point slope formula, so that's what we use. I can rewrite it in slope intercept form simply by moving this 5 over, subtract 5 from both sides. So we get y equals 6/5 x minus 5. So there's where it is. They're both the exact same thing, using the exact same method. So let's look at one more. We turn around and try to keep this time down fairly close. 4, 1, and -4, -3. Okay? So here again, using point slope and slope intercept formula. So in point and slope intercept, if we wanted to write it as y equals mx plus b, and you did a lot of this last year. Okay? This one's going to be y minus y1 equals m times x. Oops. on my review button. X minus x1. Okay, so in doing this one real quickly, we need to find the slope in both of them. So slope, I'm going to go quick. So slope, changing the y's from 1 to -3. Well, that's a change of -4 over, how far do we change from 4 to -4? That's a change of -8. Hey, the negatives cancel, and 4 divided by 8 is 1/2. So my slope is 1/2. Slope-intercept form. We don't have the y-intercept up here. So not necessarily the cleanest of these. It would probably lend itself to point slope here. So let's go ahead and pick a point. I like this point, so let's plug this one in. So y minus, what's our y value? 1 equals our slope. 1/2 times x minus, what's our x coordinate? 4. All right, so distributive property here, nothing to do here. Y minus 1 equals 1/2 x. 1/2 times -4 is a -2. So now what do? Got to get this over to the other side. So add 1 to both sides. We get y equals 1/2 x minus 1. There it is. So could we have done that with slope-intercept form? Sure. The problem is we don't have a b here. So in order to find the b, much like point slope, we're going to have to plug in a point. We're just going to plug them in here for the x and y. So this is what we would do. We would choose a point again. Here's our x, here's our y. So going using y equals mx plus b. Y coordinate is 1. M, our slope, 1/2. X, our x up here was 4, plus b. So we've got 1 equals 1/2 times 4 is 2 plus b. Subtract 2 from both sides, and we find that our b equals -1. Now we have our slope and our y-intercept, so now we can write it slope-intercept form. So, all right, so hopefully that helps. Give you a quick review, quick reminder. So we'll take it from here, kind of move things along as we're going forward, and I will see you back in class.